Hi class, let's take a look at a couple of problems where they want us to evaluate. Now, for problem one, here's what we have. So we have an equation, and let me just box it in. And in this equation, they want us to plug in a couple of values. So we technically have an m, an x, and a b. So let me rewrite it. So y is equal to, I'll put a parenthesis on the m, one on the x, and on the b. And y is equal to, m is equal to 1. So technically, that takes the place of 1. X is equal to a half. And b is 3/2. And then the main idea is that once you plug in the corresponding values, we're going to actually simplify as much as possible. So in this case, we're going to end up with y is equal to 1 times a half. This is just going to be a half plus 3/2, or, well, 1 plus 3 divided by 2, 4/2, or the values of 2. So let me just rewrite the final answer. Our final answer here is that y is equal to 2. And let me just check m, x, and a half. That's actually it for this problem. We do have to be careful because some of the problems, they will want you to evaluate and then solve for a variable, such as problem 2. Okay, so this formula, a little bit more messy. And let me plug in, or let me put a parenthesis on the values that we're going to be evaluating. So m, x1, and y1. So y minus technically y1, it's going to be equal to m times x minus and x1 here. So y minus, or y1 is 4. This is equal to, our m value is 2 times x minus, and your x1 is equal to 3. Okay, at this point, let me just rewrite it and remove the parentheses on the left hand side. So we technically have y minus 4 is equal to 2 times x minus 3. So there's no need to keep the parentheses. There's no negatives since x1 is a positive. And then they do want us to solve for y. So what I'm going to do here is add the 4 to both sides. And this is going to give us y is equal to 2 times x minus 3 plus 4. Now, this answer has already been solved for y, but not simplified, because technically you could distribute the 2, which is going to give us, in this case, y on the left, and this is equal to 2x minus 6 plus 4, or y is equal to 2x minus 2. And that would be our final answer. Technically, the previous one could be considered not completely simplified, because you can still rearrange the constants. So that's going to be our final answer for this one. Let's move on to problem 3. In problem 3, we have an A, B, and a C. And let me just put parentheses on all of those. So technically A, X plus BY is equal to C. And they also want us to solve for Y. So A, it's a 2. X plus B is 4. Y, this is equal to technically 7 on the right hand side. No double negatives, so let me just remove the parentheses. So we're looking at 2x plus 4y is equal to 7. And they do want us to solve for the y's. So let me subtract the x's. So we would have 4y is equal to negative 2x plus 7. And then notice that we have a 4 multiplying the y. So we could divide by 4 and divide by 4. And this one has two possible answers. So we could express our final answer as negative 2x plus 7 over 4. It's perfectly fine because it's been isolated. But technically, you could go further and reduce the fractions. But if you go this route, you have to rewrite it as follows. Negative 2x over 4 plus 7/4. And this is the fractions that I'm referring to reducing. Only this one reduces, the 7/4 remains. So we would end up with y is equal to negative 2 times x over 2 times 2 plus 7/4. And then another perfectly fine answer, it's going to be y is equal to negative x over 2 plus 7/4. That's actually it for this one. Let me check again the answers. In this case, this is perfectly fine, but we could reduce that. So you end up with a 2 negative. Yep, that's pretty much it for this one. And I think we have one more problem, which is a little bit messy. Okay, so let me rewrite the formula with the parentheses, no negatives. So I'm just gonna actually evaluate them. So m is equal to, your y2 is a third. So we end up with 1/3 minus, and notice that that's your y2 minus your y1, that would be 2. All over your x2 is a half minus your x1 is 3. Okay, the fastest way to simplify this fraction is to find the LCD, which in this case it's 6, multiply the top by 6 and multiply the bottom by 6. What this is going to do is it's going to technically reduce all the fractions, but it does make a mess. So let me rewrite it so you see it. This will be 1/3 minus 2 over 1 over 1/2 minus 3 over 1. And each of these, and let me just put it in green, gets multiplied by 6. Now, here's the advantage of multiplying by 6. All of your fractions are going to reduce because the LCD is a common divisor. So let me first rewrite what doesn't actually get canceled, which is going to be the numerators. And I'm talking about the 1, the negative 2, the 1, and the negative 3. So this will be 1 minus 2 over 1 minus 3. And then let me write in green the divisions. 6 divided by 3 is equal to 2, so it'll be 1 times 2. 6 divided by 1 is equal to 6, so times 6. 6 divided by 2 is equal to 3, so times 3. 6 divided by 1 is equal to 6. And notice that in this step, there's no more fractions. So we technically have 2 minus 12 over 3 minus 18, which is equal to negative 10 over negative 15, which we cancel the negatives. And then we have, and let me just double check, 2 minus 12, 3 minus 18, 15. So we can rewrite it as 5 times 2 and 5 times 3. And this one reduces to 2/3. So positive 2/3. And let me just rewrite it. In this case, m is equal to positive 2/3. It turned out to be a little bit messy. That's because of the fractions. In this case, your second coordinate points ended up with fractions, so that create a fraction that contained fractions. Notice that the original problem was a fraction, so evaluating the fractions creates a fraction with fractions. And this process of the LCD, it's technically the fastest. That's actually it for these problems. I'll put the rest of them on a different video.